We're going to start learning about stoichiometry. So I think what I want to do is go ahead and start working some examples for you, and that'll show you best what this word means. Look at this balanced equation at the top of the page. The way that we understand this is that for every 4 NH3 or ammonia molecules, you react with 5 oxygen molecules, you're going to make 6 waters and 4 NO or nitrogen monoxides. Well, when a chemist looks at that balanced equation, they think the same thing, but in terms of moles. And that's really what stoichiometry is. You're comparing two of the substances in a chemical reaction in terms of moles. And the conversion that we're going to use in this chapter when we do our conversion factor problems is going to be called a mole ratio. Now, you actually are already familiar with stoichiometry in the kitchen. You just don't call it that. Let me show you a recipe. Here's the recipe or the equation for making a cheese sandwich. It's a really simple one. You take 2 slices of bread and 1 slice of cheese to make a sandwich. So let's use our stoichiometry idea. If I have 6 pieces of bread and 4 slices of cheese, how many sandwiches can I make? Well, what you're going to have to do is figure out how many sandwiches you could make from the bread and how many sandwiches you could make from the cheese, and then figure out which one is the correct answer. So think about that for a minute. With 6 pieces of bread, I think you should be able to make 3 sandwiches. So I'm just going to put a note right there. And with 4 slices of cheese, I think I can make 4 sandwiches because each sandwich only takes 1 slice of cheese. Now those are 2 different answers. Can I make 3 sandwiches or can I make 4? You may have figured out that you can really only make 3 sandwiches because you're going to run out of bread, and when you run out of bread you can't make any more sandwiches no matter how many slices of cheese you have extra. So let's try another one. If I need to make 14 sandwiches, how many slices of bread do I need? Well, I know from looking here that every sandwich takes 2 slices of bread. So if I want 14 sandwiches, I'm going to need 28 slices. That is using the mole ratio for stoichiometry. Let's do another sandwich problem. In this situation, this chef has 33 slices of bread and 15 slices of cheese. I want to do the same thing. I want to calculate how many sandwiches he can make from each ingredient and then figure out the correct answer. So let's start with 33 slices of bread. If I divide by 2, because each sandwich takes 2 slices, I can make 16.5 sandwiches. But you can't really have half a sandwich, so I think I'm going to say 16 sandwiches from the bread. This recipe says that every sandwich needs 2 slices of cheese, and he has 15, so that would give me 7.5 sandwiches. But remember, no halves, so I think you can make 7 sandwiches from the cheese. Again, I'm going to go with the smaller answer. You should be able to make 7 sandwiches using this recipe before you run out of any one of those ingredients. Now I know those are both kitchen examples. Let's look at one that's a totally different product. This is a tricycle recipe. In the tricycle factory, a shipment has come in. There are 400 seats and 600 wheels. So how many tricycles can be made? I want to show you this one with the mole ratio and sort of setting it up as a conversion problem. Let's figure out how many tricycles we could make from 400 seats. So I'm going to put 400 S for seats. Here's the mole ratio, or the ratio. I know that for every 1 seat you can make 1 tricycle. So seats cancels. And when you do the math, you figure out you can make 400 tricycles from those 400 seats. Let's do the same thing with the wheels. If I have 600 wheels, my conversion is going to be to cancel out wheels on the bottom, and I'm trying to figure out how many tricycles I can make on top. Now if you look in this picture, just like all tricycles, there are 3 wheels on every 1 tricycle. So wheels cancels with wheels, and you divide 600 by 3, you figure out that you can form 200 tricycles. The 2 answers are different, 400 or 200. The one that's the correct answer is the smaller one, you can make 200 tricycles with these ingredients. Alright, now let's go to the chemistry problems. Here's a balanced equation. You always need one of those. Let's figure out how many moles of water we can produce if we start with 0.176 moles of oxygen. So I'm going to write my given first, which is 0.176 moles of oxygen. And I want you to get in the habit of writing the number, the unit, and the chemical here. Now I need to convert these units. I want moles of oxygen to cancel out. Okay? And I'm going to try and find moles of water on top. What is the ratio of moles of water to moles of oxygen? Well, remember from the very beginning, that's the coefficients in the balanced equation. So there's a 6 up here with the water. I'm going to put that there. And there's a 5 with the oxygen. So I'm going to put that there. Moles of oxygen cancels with moles of oxygen. And then you're going to have to do your math. When we do the math, we're going to multiply 0.176 times 6 divide by 5. And the answer is going to be 0.211 moles of water. So I got a new number, and I don't just have moles of oxygen anymore. See how that canceled out? I've got moles of water. Let's try this next one. My given is 17 moles of water. So I'm going to write that down first. We're just converting from moles of one substance to moles of another one. It doesn't really matter about the other parts of the reaction. We are only concerned in this problem with moles of water, and I'm looking for moles of nitrogen monoxide, or NO, on the top. So you go back to the balanced equation again. The coefficient 4 is in front of NO, so that goes here in the ratio, and I need the coefficient for water on the bottom, which is 6. Moles of water cancels with moles of water, and the math is going to be 17 times 4 divide by 6. You get a little over 11. I'm just going to round off for the significant digits. It's 11 moles of NO here. And that's how you use the mole ratio from the balanced equation to do a stoichiometry problem. Alright, well, what happens if we have grams involved? Really, it's just going to involve one more step. In these problems, what we're looking at is figuring out how many grams of water can be produced if we start with moles. Alright, so again, I'm going to write my given first. 1.9 moles of NH3. See how I wrote the unit and the chemical? Let's use that mole ratio. I need moles of NH3 to cancel. Now, which chemical am I interested in? Well, the question here says grams of water. So I think I'm going to put moles of water first to get the chemical right, and then I'll get the unit right in just a second. The ratio in the balanced equation of water to NH3 is 6 to 4. Moles cancels with moles. Now I need to get grams. Can you remember how to convert moles of water to grams of water? That's a review conversion. I'm going to put 1 mole of water on the bottom so that those units cancel, and I'm looking for grams of water. What you're going to need to do is get your periodic table out, get the molar mass of water, 2 hydrogens plus 1 oxygen, and what you should get for that total is 18 grams. Now moles of water here cancels with moles of water. The math is going to be 1.9 times 6 times 18. Multiply all those numbers across the top, and then divide by 4 on the bottom. And you get 51.3. So I'm going to round that off to 51 moles. Oops, sorry, it's not moles. I'm going to round that off to 51 grams of water. That's the unit that I'm left with right there. So if you react 1.9 moles of NH3, you will make 51 grams of water. Alright guys, last one. I'm starting with 0.3 moles of water. So I'm going to write that as my given. I need to figure out oxygen in this problem. So I want these moles of water to cancel on the bottom, and I want moles of oxygen as my new chemical. Remember, we'll fix the chemical first, we'll fix the unit second. So moles of water here will cancel with moles of water given. The ratio of oxygen to water in this balanced equation is 5 to 6. And then I need to get grams of oxygen. That's the review. So how many grams of oxygen are in 1 mole? Go to the periodic table and add up 2 oxygens. You should get 32 grams. So moles of oxygen there cancels with moles of oxygen there. We're going to multiply straight across again. 0.3 times 5 times 32. And then I'm going to divide on the bottom by that 6. That gives me a total of 8 grams of oxygen. So we've compared. In this first problem we compared NH3 to water. And in the second one we compared water to oxygen. Those other chemicals didn't make a difference. And the only step we used the balanced equation for was this new conversion factor. Remember, it's called the mole ratio. So I've got plenty more to practice next time we're together. Good luck. Bring your notes. I'll see you then.